Hello guys, how are you all? Hope you are doing good. Today we are going to study about modern physics. In modern physics there are 5 chapters we have to study. The first one is photoelectric effect, the second one is atomic physics, the third one is X-rays, the fourth one is nuclear physics and the last one is semiconductor physics. In photoelectric effect we first have to study about Planck's theory. What does Planck's theory says about that? Planck says that in this universe each and everybody continue emitting and absorbing energy in the form of electromagnetic radiation from the surroundings, which is called quantum, which is later called photon. This energy is directly proportional to frequency of the radiation. That means E is directly proportional to F, and we all know that frequency is equals to c by lambda, where c is called speed of light and lambda is its wavelength. So by removing its proportionality constant, we have to mention here a constant which is called Planck's constant. Alright guys, so here energy of photon. According to Planck's theory, energy of photon is directly proportional to the frequency of light. So E is directly proportional to, here frequency is nu. So removing here proportionality constant, there is a constant term h will be placed here. So h is Planck constant. H equal to 6.62 into 10 to the power minus 34 joule second in the form of joule and second, and in the form of electron volt into second, 4.14 into 10 to the power minus 15. Okay, so we know that C is equal to frequency into wavelength. Wavelength, that means in meters, and with frequency per unit second. So meter per second here is the unit. So C is the speed of light, mu is the frequency of light, and lambda is the wavelength of light. So E will be, according to Planck's law, E equal to h nu. So nu can be written as c by lambda. So here the formula becomes hc by lambda. So C is equal to 10 to 3 into 10 to the power minus plus 8 meter per second in vacuum. So this both terms is constant. Almost this is constant term. So multiplication of these two terms is 1242. We have to remember these things. 1242 divided by lambda, where 1242 unit is electron volt and lambda should be in nanometer. We have to remember these things. Okay, coming to the next slide. Now momentum. Momentum is denoted by P. So momentum is equal to energy by speed of light. So E by C, where E is equal to hc by lambda, and C and C is cancelled out, so P equals h by lambda. The next one is effective mass of the photon. So according to Einstein photoelectric equation, theory of relativity, E equal to mc square, so m equal to E by c square. So E equal to hc by lambda divided by c square. So h by lambda into c. So h and c are constant. So m is inversely proportional to wavelength of light. So as the frequency increases, mass will be decreases. So next is intensity of light. So intensity, the definition of intensity is energy per unit area per unit time. So energy by area divided by time is called intensity. So I equal to, it is denoted by I is equal to E by AT. So E is equal to, E by T is equal to power. Here P is power and there P is momentum. We have to remember that one. So P by A. So I equal to P by A. That is equation number 1. We have to mention here. So now coming to the next slide. Suppose there are n photons incident on any material surfaces, so intensity becomes n times, so n multiplied by E by AT. So E by T is equal to power. So in this way energy can be written as hc by lambda, so n hc by lambda into A. This will be equation number 2. From equation number 1 and 2 we will get P by A equal to n hc by lambda into A. Here A and A will be cancelled out. So in this way we can write here n is equal to P into lambda. This is cross multiplied divided by hc. So P is the power and lambda is wavelength h and c are constant. H is Planck constant, c is speed of light. So here we can, this is the formula, we can find out the number of photons, how many number of photons is incident on a surface where power is generated at this wavelength. Okay, so next one is force exerted by photon. If a photon insert impact on any metal surface, so definitely there will be a force exerted by these photon particles. So we will consider different cases here. So if the surface is perfectly perpendicular collision and perfectly reflecting body, so as the force incident on that surface, the same is reflected by that surface also. So incident momentum is equal to reflected momentum, but direction will be different. So incident momentum is equal to n into h by lambda, where momentum definition we already know, h by lambda. So n into h by lambda, and return momentum will be same, nh by lambda. Change in momentum, so rate of change in momentum is, we know that this is force, so change in momentum per unit time, so time is equal to 1, so time is not mentioned here, so minus 2 into h by lambda. According to Newton's third law, action is equal to reaction, so force exerted on the plane is equal to plus 2n into h by lambda. In this way we know that here lambda and sc by lambda, h and l will be cancelled. In the form of power we can write here F is equal to 2p by c, where p is called power. So in this way pressure on the surface we can write here force per unit area in this form. So here area term will be added in the lower section, in the denominator. Now force at any angle. If the photon particle impact on the surface at any angle theta with the vertical plane, so here a cos theta term will be added, and the vertical component of that force will be cancelled out by each other. So equation will be same, but additional a cos theta term will be added here. If the surface is perfectly absorbing surface, so the return component of the force will be 0. Okay, so force becomes p by c only, and pressure becomes p by ac. So we will discuss about the numerical portion in next video. Thank you so much.